The plastic glasses might seem like they have to be thrown away just because they're broken, but in fact, you can completely repair them in just a few minutes with a very simple trick. The bridge of the glasses has completely broken into two separate halves, causing the two sides of the frame to lose their connection. The fracture occurs at the most stress-bearing point, leaving the plastic surface sharply cracked with uneven, broken edges. With the bridge of the glasses completely broken in half like this, in today's video I will share how I weld the two plastic pieces back together, helping restore the glasses' strength so they can be used again almost like before. I will remove the temple arms to make the repair process easier to handle. Once both sides of the arms are detached, the front frame becomes more flexible, allowing me to precisely align the broken section and carry out the bonding process more conveniently without obstruction. Next, I'll carefully wrap the lenses with tissue paper to protect them from scratches during the repair process. This layer helps prevent dust, heat, or accidental contact from damaging the lens surface while I work on fixing the broken frame. Next, I will secure both lenses onto a flat wooden board using tape to keep them from shifting during the repair process. After that, I'll carefully realign the broken bridge so that the two fractured parts fit together precisely, ensuring the frame returns to its original shape. After accurately aligning the broken parts, I will apply a small amount of super glue to the contact surface and gently press the two pieces together. The adhesive will temporarily hold the bridge in the correct position. However, to make the joint truly strong, I will reinforce it by adding small metal pieces inside the repair area. Here, I'll use a safety pin and cut it into small metal segments to serve as reinforcing bars. If the plastic is welded alone, the bond usually remains only on the surface and can easily break again when subjected to stress. After cutting them, I will place these small metal pieces along the broken bridge so that they span across the cracked area. I'll use a preheated welding tool and gently press onto the metal pieces, allowing them to slowly sink into the plastic. As the plastic melts and wraps around the metal, the reinforcement becomes firmly embedded inside, creating a strengthened joint that is much more durable and resistant to stress. After the metal pieces are embedded into the plastic, the structure of the bridge now works similarly to reinforced concrete. The melted plastic acts like the outer concrete layer, while the metal pieces inside function like steel reinforcement that improves strength and load resistance. As a result, the previously broken area is not only rejoined but also becomes much sturdier and more stable compared to a simple glue repair. To further strengthen the repair, I'll continue welding several more small metal pieces into the surrounding area of the bridge. By extending the reinforcement beyond the original crack, the stress can be distributed more evenly across the frame, allowing the repaired section to become much more solid and durable for long-term use. After completing the welding process, the metal pieces are firmly embedded inside the plastic, and the bridge of the glasses is now fused back into a single solid piece. The repaired area may appear slightly uneven due to the melted plastic, but the overall structure has become rigid and no longer feels loose as it did before. The surface may still have some uneven dents and bumps because the melted plastic did not float evenly. Therefore, I will continue refining this area to balance the surface. For this step, I will use this battery and remove its outer casing to extract the graphite core from inside. After extracting the inner core, I will gently scrape its surface with a knife to obtain a fine black powder. This powder will be used as a filler material for the repaired area, helping to fill in the remaining dents while also maintaining a color that closely matches the original frame. I will sprinkle the graphite powder evenly over the repaired surface and apply a small amount of super glue to bond it in place. Once the adhesive fully dries, the filled area will become solid, and all that remains is to sand again to achieve a smooth and uniform finish. Since the surface after welding is still slightly rough and not very aesthetic, I will sand down the repaired area to smooth it out. For small details like this, sanding with standard tools can be difficult to control. So I will make a mini roller wrapped with sandpaper on the outside to handle the job more precisely. Here, I will use a rivet as the main shaft, then wrap a layer of sandpaper around it to create a mini sanding roller. I will use both coarse and fine sandpaper during this process. First, the coarse sandpaper helps quickly remove excess plastic and level out the raised areas on the surface. Then, I switch to fine sandpaper for final finishing step, making the bridge area smoother, more even, and giving it a more natural-looking finish after the repair. After finishing the homemade sanding roller, I will attach it to the drill to begin working on the surface. After completing the coarse sanding step, the bridge area has been significantly leveled, with most of the large bumps and excess plastic removed. The repaired section now appears more aligned with the original frame. Although the surface is still slightly rough and shows small scratches left by the coarse sandpaper, the overall shape has been clearly restored and is ready for the fine sanding stage. In this fine sanding step, I will spray a layer of water onto the surface before sanding. The water helps reduce friction and minimize heat buildup during the process, while also washing away plastic dust to achieve a smoother finish. As a result, the bridge area becomes more even and polished, while preventing the repaired plastic from overheating or deforming. After completing the fine sanding process, the surface of the bridge becomes noticeably smoother and more uniform. The scratches left from the coarse sanding are largely removed, and the repaired area blends more naturally with the surrounding frame. The transition between the original plastic and the repaired section now appears much cleaner, giving the bridge a refined and solid finish. After the surface has been fully smoothed, I will repaint the repaired area to restore the overall appearance of the glasses. I will reinstall the two temple arms back onto the frame. Once both sides are securely attached, the glasses return to their complete structure, and the repaired bridge is now ready for normal use again. Next, I will dip a cotton swab into the paint and carefully apply it onto the repaired surface. Using a cotton swab allows better control when working on small areas, helping the paint spread evenly while avoiding excess buildup around the bridge section. This repair method proves to be both practical and effective. Instead of discarding a broken pair of glasses, a simple combination of plastic welding and internal reinforcement can restore both strength and usability. Then, I will leave it for a short while to allow the paint to dry properly before moving on to the next step. After drying completely, the painted surface becomes smooth and uniform, blending well with the original color of the frame. The repaired area now looks much cleaner and more refined, with the repair marks greatly reduced and the bridge appearing solid and visually restored. After the repair is fully completed, the bridge of the glasses feels solid and firmly connected once again. The frame no longer shows any signs of looseness or flexing at the previously broken point. Thanks to the internal metal reinforcement and plastic welding, the repaired area is strong enough to withstand normal daily use, providing a stable and reliable structure similar to the original condition.